Yes, sir.
Okay, fine. Okay, now we'll start our next unit. Okay, this is your second unit, moving loads and influence line. So what is this basically? Moving loads and influence line. Okay, so all of you know, I think, when you did your analysis in your third, fourth sem and earlier fifth sem also design and all these things, you did, I think, for all of you did, it is for dead load only. Okay, by considering the dead load as per IS 456 and all these things, all the codes. So now in this case, what we need to do, we need to consider the moving loads also. Okay, moving loads is nothing but the live loads. So what is the effect of the dead live load? Along with the dead load, we need to analyze that and we need to design as per that. Okay, so li- for live load, the most common example is you can take for the bridge. Okay, uh, in the bridge the vehicles are moving from one end to another and the load is not fixed, it is a moving load. So it affects the structure differently from at every point. Okay, so it is basically about that. Okay, how it affect. So let's go through this. So this is the basic introduction part. So when applied load is not fixed, that is moving, we use influence lines to determine the impact of live moving loads at a single point as the load moves across the beam. Okay, influence lines are important in the design of structure that resist live moving loads. So influence lines is what? This is basically the representation of that live load moving from one point to another. Next, what the common sense tells us that when a load moves over a structure, the deflected shape of the structure will vary. In the process, we can arrive at simple conclusion that due to moving load position on the structure, reactions value at the support also will vary. Okay, as per the load, the reaction will be varies. All of you know that. So as if we can say that if a 1 kilonewton load is applied, as per that load, the structure will reflect in a different way. As per that load, the reaction will be different. So similarly, if we sense the load, it will also give some different value. Okay, so from the designer point of view, it is essential to have safe structure which does not exceed the limit of deformation and also the limits of load carrying capacity of the structure. So what we will come to know by doing this analysis, by doing the influence line diagram, we can say that how much the load a structure will we can withstand during its lifespan. So according to that, we can design a structure, we can construct a structure. So for that, we must know what kind of load and what will be the effect of that load in this type of structure. Okay. So what is the definition of influence line? It The definition of influence line is given by different researchers by different way. So this is there are some basic definition of this. So please go through this. An influence line is a diagram whose coordinates, which are plotted as a function of distance along the span, give the value of an internal force, a reaction, or a displacement at a particular point in a structure as a unit load move across the structure. All of you please listen carefully. Remember this term, unit load. Unit load move across the structure. Whenever we analyze to find out the influence line diagram, we always consider the load as a unit load. Means we consider the load as 1. Okay, we need to consider the load as 1. Why we consider this? Because if you consider a load as 1 unit load, by considering unit load, if we calculate all these things, then we can easily say for 10 kilonewton, for 5 kilonewton, what is that? So, so as per that, we can design the structure. So an influence line is a curve, the ordinate to which at any point equals the value of some particular function due to unit load acting at that point. An influence line represents the variation of either the reaction, shear, moment, or deflection at a specific point in a member as a unit concentric force moves over the member. Okay. By considering that unit load, what we need to do, we need to move that along the span of the structure, but at different point, at different time, we need to consider that load, and we need to analyze, and as per that we need to design. Okay. So why do we need the influence lines? So please go through this. When loads pass over a structure, for example a bridge, one needs to know when the maximum values of shear, reaction, bending moment will occur at a point so that the section may be designed. So all of you know that if we know the reaction, if we know the shear, if we know the bending moment, so we can easily design a structure by considering that load, that shear force, and that bending moment. Okay. So there are two ways of drawing this construction of influence line. This is the two basic ways by which we can draw this influence line. So what are these two approaches? One is tabulated values and one is influence line equation. So we will discuss about this in the next presentation. Okay. So we will discuss in this presentation. So how, what is the procedure to determine this influence line? Okay. So all of you please go through this point wise. The first point is place a unit load, a load whose magnitude is equal to 1. All of you please remember this. We need to consider a unit load. Okay. At a point x along the member. Say a beam is given. So along that beam at a distance x, we need to consider a load, a unit load is applied. Okay. Next, use the equation of equilibrium to find the value of function, reaction, shear or moment at a specific point P due to the concentrated load X. So at that distance X, we need to find out the reaction, shear and moment. Okay. So after that, we need to repeat this force over the whole section. Okay. So after knowing this, we need to plot the reaction, shear or moment for the member. So by equation using that is the tabulated value way, and for the influence line equation, what we need to do again, we need to do the same things almost. Again, we need to put a unit load at a section X along the member. Then we need to use the equilibrium equations. After that, we need to find out the moment, shear force, and reaction. And finally, we need to plot the all the values in a to draw the shear moment and all these things. So I think all of you know how to draw the shear force, bending moment for a beam and all these things. So now can anyone say me what is this equation of equilibrium? Can anyone say me what do you mean by these equations of equilibrium? Anyone please respond. Have you heard about this term earlier? Equations of equilibrium. Am I audible to you?
Yes, sir, we can hear.
Okay. Can anyone say me what is the equation of equilibrium? Is there anyone? Have you heard about this term earlier?
Summation,
Equilibrium. What are the equation of equilibrium?
summation of vertical force and
Yes.
horizontal force G is
Yes.
zero.
Okay, fine.
Summation of vertical force, yeah, and
Yeah,
horizontal force is zero.
summation of vertical force, summation of horizontal force, and summation of moments is is equal to zero. These are the three basic equilibrium equation. All of you remember this thing, okay? These three are the basic equilibrium equation of summation of h, summation of p, and summation of m. We can shortly say like that. This summation of h means horizontal force, summation of p means vertical force, and summation of m means moment. Moment. Okay. If we can, we need to resolve these three. Okay. So now, all of you please check this. Okay. This is a simple example how we need to draw this influence line. Okay. So here you see. First of all, what we need to do, we need to find out this reaction, shear, or moment. Okay. So this is an example, numerical example is given. So please go through the question. Construct the influence line for the reaction at support B for the beam of span 10 mm, sorry, 10 meter, and the beam is given like this. Okay. This is simply supported beam A and B. That's span is given 10 meter. So we need to find out the reaction at support B. So how we will calculate this? Okay. All of you please go through this. Very easy. So as you know, there are two ways. So first we use the tabulated value. So for that, what we need to do, see here, in this diagram, what we consider a load. This arrow, I think all of you are able to see this. A arrow is given at a distance x from the point A. Okay, and this load we consider as 1. Please remember this. It is written as shown in the figure. A unit load is places at a distance x from support A, and the reaction value Rb is calculated by taking moment with reference to support A. So what we did, let's say we consider this x at a distance 2.5 meter from support A. So as per that, what we need to do, we need to find out the reaction at B by considering the point A, by taking the moment about A. So all of you know, I think, how we need to find out. This is very simple calculation. This it is given Rb into 10 minus 1 into 2.5. It is given from the upward direction, that's why it is minus. Okay, we are taking moment about A. So from this we can easily say what is our Rb value. Okay, so next what we did, similarly what we need to do, we need to put this load at different position along this beam. Okay, suppose we say that first we consider at 2.5, next we consider at 5, next 7.5, similarly up to 10 meter. Okay, by doing that, you see, if we calculate this Rb from 0 to 10, you will get this value. If we calculate by considering this reaction, by taking the moment about the support A, you can easily calculate this Rb. All of you understand this? Please respond. If you have any doubt, please feel free to ask, or we will move to the next. Okay, please clear your doubt in every step. And see, it is not like that you need to consider at 2.5 meter only. It is not like that. You can also consider at every 1 meter interval, zero point 0.5 meter interval, zero point 0.2 meter interval, or 2 meter interval, like that. But remember that consider the interval as equal interval. Okay, you can also consider in between also, but for your drawing and for easy calculation, you consider at equal interval like 2 meter interval, 2.5 meter interval, 1 meter interval, zero point 0.5 meter interval. It's up to you at which interval you consider this load. Okay, according to that you have to go from 0 to 10 meter in this table. See here, 0 to 10, 0, 2.5, 5, 7.5, 10. Here we consider as 2.5 interval. You can also consider as 2 meter interval. Okay, which okay, just give me a second. Okay. Okay, so I think all of you understand this, how we need to consider this interval. So as per that interval, you need to find out this reaction, okay? And also remember one thing, okay? See, whatever interval you consider, suppose it is 0, 2.55, 7.5, 10, or 0, 2, 4, 6, 8, 10, or 0, 1 to 10, whatever you have considered, remember one thing, that when you consider the interval and when you calculated this reaction, always remember at starting point you will always get 0, and at the ending point you will get always 1. Okay, if you getting something different, it must be wrong. Okay, so after finding out all this value, you see you will get a curve like this. See, this is the final representation of influence line at reaction B for reaction RB. Okay, similarly you can also draw for RA also. Only different is your diagram will be look opposite of this. It will start from RB to RA. At RB you will get 0, at RA you will get 10, 1. Okay, so this you see simple equation. RB, just put x by 10. After simple calculation from this you can also derive RB is equal nothing but x by 10. So just put the x value, you will get this RB value. Okay, so by finding out this thing, you need to draw this influence line diagram. Is it clear to you?
Sir.
Yes. Here you see this, how you have calculated. It is very simple. The reaction, just put the x value and you can easily find out this. Okay. Is there anyone have any doubt in this? See. Okay, let's move on. Okay. So now here you see. For I think all of you know there are two type of structure. One is determinant structure and one is indeterminate structure. So what is the difference between these two? Okay, there is a simple and basic difference between these two is if a structure is resolved by the three equilibrium equation, the three basic equilibrium equation which we already discussed, summation of H, summation of V, and summation of M. If we by using these three equation, if we analyze a structure, then we can say that this structure is a determinant structure. For example, you can say simply supported beam or cantilever beam. Okay, or if we are not able to analyze a structure by using these three basic equilibrium equation, then we can say that structure is a indeterminate structure. All of you please remember this. This is a very basic common question asked in every exam. Okay, what is determinate structure and what is indeterminate structure? For indeterminate structure, we can say this example is continuous beam. Okay, so here you see, as I have already said, this is the same thing. There are two types of load, dead and live load. In all our previous analysis, we have analyzed the beam for dead load only, where position of the load is fixed. But in case of moving loads, for example, in road bridges, the position of loads continuously changes. Thus, to calculate the maximum shear force and bending moment in such type of beam require a different analysis. And this analysis is known as ILD, influence line diagram. Okay, so what is this influence line? I have already discussed. ILD are drawn for area stress resultant like reaction, shear force, bending moment at specified point. ILD for a stress resultant is the one in which coordinate represent the value of the stress resultant for the position of the unit load at corresponding position. Okay, here you see this is a representation of ILD of a beam. We are considering a unit load. This one at a section X. So if we draw, we'll got something like this. Okay, so we'll discuss one by one about this. How it for ILD for SSB means influence line diagram for simply supported beam, continuous beam. We'll discuss about this one by one. Okay, is there anyone have any doubt up to this? All of you please give your attendance in the chat box. Okay. All of you please go through the notes. Okay, whichever I have given to you. And if you have any doubt, please feel free to ask me. Okay. Anyone have any doubt up to this? If you go once through the notes, if you feel any doubt, please ask me. For your reference, I will give you the presentation and some PDF also. All of you please refer that for your understanding. Okay, as you have not asking any question, I will say one thing. Okay, I think some of you may ask why we need to consider this unit load. So remember that we are analyzing this type of structure for moving loads. Okay, earlier whatever analysis you did, you did for dead load only, but this time we need to consider the live load. This is live load is moving load. Okay, so if you say for a bridge, vehicles are moving through that bridge and it is not fixed. Okay, so the load is moving from one point to another, and the load movement of load is not fixed at a particular point, so it is moving through the bridge. So if we analyze a structure like that by considering a unit load, at which position what is the impact of the load as per the distance, say we consider at the distance x, like at a, by considering some interval. So but if we do that by taking some interval and if we analyze the structure according to that, then we can easily say that at which distance what is the effect of that load on that structure, and according to that we can design or we can analyze a structure. So by for knowing that, what we need to do, we need to consider a unit load. By considering that unit load, we need to analyze the structure. So you may ask why we need to consider unit load, why not others? Say if we design or if we analyze anything by considering a unit load, so what will it will help us? Say if we know what is the impact of a unit load, if someone asks you what is the impact of 20 kilonewton, say 30 kilonewton, 50 kilonewton, what we can do? We can easily multiply that load into the first for the analyze we did for unit load. So if you know, if you able to know by for unit load, you can easily say for any kind of load. That's why we are considering as a unit load. Okay. So by considering unit load, we did this analysis. Okay. So for that analysis, we always need to consider a unit load. And remember, this is a basic question asked in every question, every exam. Okay. In your final exam also, you may get MCQ. If there is MCQ, you may also get a question like this. For analysis of influence line diagram, what type of load we need to consider? So your answer should be one. Okay. Or unit load. In the option, if it is given one, you should go for that, or in the option if it is given unit load, you also go for that. Okay, so remember this, don't forget this is very important and basic thing. Is it clear all of you? Because yesterday one student asked this question in section B, but for your section I think all of you have understood everything, that's why there is no question. It's good if you are understanding. Are you all present here, or all of you are just joining and leave, as I am not able to see
Present,
you?
sir.
Can you all turn on your video? It's very long. We are not able to see each other. Just for a second, if you turn on your video. Yes, Vicky, how are you?
Good morning, sir.
Good, sir. Good
Uh,
morning.
okay, all of you turn on your video. I just want to see all your face.
Yours are turn, sir. On.
I am there. I am speaking continuously. Without I am here, how can someone speak? Are you all able to follow these things? Is it okay with you, or are you
Yes,
able,
sir.
or you are getting difficult to follow this? Okay, I am here also. Okay, are you able to see me? What about
Yes,
the
sir.
others? They are just joining and leave, I think, na? I will not give attendance to them. Those who are not turning on their own video. Ah,
Morning, sir.
one by one, they are coming.
Good morning, sir.
Good
Sir,
morning, good morning.
Sir,
sir,
low network connectivity.
Yeah, Stephanie is there. You are active, I know. I'm, I'm regularly coordinating with you by sharing all these things. All of you got the
wrong
notes and all
answer.
these things, what we have shared in your group.
Yes, sir, I've shared everything in the group, sir.
Okay, fine. All of you, please go through that. Okay, everything is well explained because yeah, what happened last time when we did the class in the classroom itself, na? I'm able to use all the board and all these things, and it is very difficult to explain analysis by in laptop. I think all of you
Mm,
understand this.
Yes, sir.
This type of subject is very difficult. For theoretical subject, it is okay to explain.
yes, sir.
But for analysis and all these things, I am also getting difficult to explain you well. I think you are not able to understand everything. But I'm trying as my best to give you all the things, all the necessary notes and all these things so that you can follow. And if you study one by one, you can easily understand. Okay, it's all very well explained. It is in a very simple language also. So I may give you lots of things. All of you
Yes,
please
sir.
take the reference and go for the class notes which I have given a PDF file, handwritten PDF file. That is we did in the last year, okay, in the classroom itself. And you will also get the question and all these things regarding that only, okay. Similar kind of things you will get in your exam. If hopefully all the condition will find very soon, we will meet each other very soon in the classroom.
Yes, sir.
Okay, and I am also not here in editive for a long. I'm going to leave editive very soon.
Oh, why, sir?
It's just some personal reason. But before that, I want to finish your syllabus and all these things as much as possible. Okay.
Oh, okay, sir.
Yes, sir.
Okay, sir.
Okay. Others are not turning their video. They are not there. I will give
Sir,
attendance only. Vicky, Benboy, Hirok, Ige Padu, Stephanie, Solomon. Only this. And Solomon, yes, Solomon is there. Ego is there. Elsang is there.
Sir,
Others are
yes,
not
sir.
there.
sir,